Complex numbers. We are going to study some basics. Iota square equal to -1. Iota power 4m equal to 1. Iota power 4m plus 1 is iota. Iota power 4m plus 2 is -1. And iota power 4m plus 3 equal to minus iota, and m is any positive integer. Any complex number z is written as a plus ib or x plus iy, where a is real z and b is imaginary z. Complex conjugate z bar is written as a plus ib. If we multiply z bar, we will get a square plus b square. Let's see some properties. So, z1 plus z2 complex conjugate is equal to z1 complex conjugate and z2 complex conjugate. z1 minus z2 complex conjugate is equivalent to z1 complex conjugate of z1 minus complex conjugate of z2, and z1 dot z2 complex conjugate will be equal to z1 complex conjugate times z2 and modulus z will be root of a square plus b square, and also modulus z bar will be same a square plus b square under. Let's see what is argument. So z equal to a plus ib. So arg z or amplitude of z is equal to b upon a. If z equal to 0 plus iota 0, then arg z does not exist, is not defined. Z can be also written as z equal to r cos theta plus iota r sin theta, or r times cos theta plus iota sin. Now arg z1 z2 is equal to arg z1 plus arg z2 arg z1 upon z2 equal to arg z1 minus arg z2, and triangular inequality. Part A, modulus z1 plus z2 is less than or equal to modulus z1 plus modulus z2, and modulus z1 minus z2 is greater than or equal to modulus z1 minus modulus z2. Now let's see some questions. Argument of a complex number z is, as I told you, z equal to here 0 plus iota 0, and arg z is given by b upon a when z equal to a plus ib. In this case, arg z is not defined. Consider next question. In which quadrant of complex plane will 1 plus 2i divided by 1 minus I lie? Let's see the solution. So 1 plus 2i divided by 1 minus I. We can rationalize it. So 1 plus I divided by 1 plus I. This will give 1 plus 2i plus I minus 2 divided by 2. That is minus 1 plus 3i divided by 2, or minus 1 by 2 plus 3 by 2 iota. Clearly, this is second quadrant. Now consider next question. Derive the condition when Z1 plus Z2 modulus equal to modulus Z1 plus modulus Z2. So let's see the solution. Z1 equal to R1 cos theta 1 plus iota sin theta 1, and Z2 equal to R2 cos theta 2 plus iota sin theta. Now Z1 plus Z2 equal to R1 cos theta 1 plus iota sin theta 1 plus, yeah, R1 is common, plus R2 cos theta 2 plus iota sin theta. We can write real and imaginary parts together. R1 cos theta 1 plus R2 cos theta 2 plus iota R1 sin theta 1 plus R2 sin theta 2. Now we find modulus Z1 plus Z2 will be equal to square root of R1 cos theta 1 plus R2 cos theta 2 whole square plus R1 sin theta 1 plus R2 sin theta 2 whole square. That comes out to be R1 square plus R2 square plus twice of R1 R2 cos theta 1 cos theta 2 plus sin theta 1 sin theta 2. This term equal to cos theta 1 minus theta 2. So we write Z1 plus Z2 modulus equal to R1 square plus R2 square plus twice of R1 R2 cos theta 1 minus theta 2. It's given that modulus Z1 plus Z2 is equal to modulus Z1 plus modulus Z2. It is only possible when this term becomes 1. That is, cos theta 1 minus theta 2 equal to 1. It means theta 1 minus theta 2 must be 0, or theta 1 equal to theta 2. That is, arg Z1 must be equal to arg Z2. This is required condition. Now, let's see next question. If modulus Z equal to 0, then prove that complex number minus 1 plus 5Z is situated on a circle. So let's consider its solution. Minus 1 plus 5Z is written as x plus I y, or 5Z equal to x plus 1 plus iota 1. Taking modulus, 5, 5 times modulus z equal to root of x plus 1 whole square plus y square. But modulus z is given as, it's not 0, it is 2. So here 5 times 2 equal to root of x plus 1 whole square plus y square. Squaring both sides, x plus 1 whole square plus y square equal to 10 square. Equation of circle is x minus h whole square plus y minus k whole square equal to r square. Clearly, equation 1 represents a circle with the center minus 1 comma 0 and the radius 10 units. Now consider next question. A complex number z satisfies modulus z minus 5I is less than or equal to 1 and argument of z is minimum, then what is z? Clearly, z minus 5I modulus less than or equal to 1 represents a circle with center 0 comma 5 and radius 1. So we can draw it. This is x-axis, this is y-axis, this is center C, which is 0 comma 5, and we draw it, and then from here this angle is theta. So this will be 90 minus theta. So this point is O, this is P, this is perpendicular. So CP, which is the radius of the circle, is 1 and OC is 5. OP can be found by using Pythagoras theorem. So OP is equal to 5 square minus 1 square, that is root 24. From here, we can get sine theta and cos theta also. So let's draw triangle in proper way. So here, hypotenuse is 5, perpendicular CP is 1, and base OP is root 24, and this angle is theta. So from here, sine theta will be perpendicular upon hypotenuse 1 by 5, and cos theta will be base upon hypotenuse root 24 upon 5. Now we can write z as OP cos, argument of z will be 90 minus theta. So 90 minus theta plus iota times OP sine 90 minus theta. That is OP times sine theta plus iota times OP times cos theta. We can put the values of OP as root 24 and sine theta as 1 by 5 and cos theta as root 24 by 5. So we get z equal to root 24 upon 5 plus 24 upon 5 iota. This can be further written as z equal to 2 root 6 divided by 5 plus iota times 24 upon 5, which is our answer. Thank you.